There is the whole page. You've seen everything on the top. I'll leave it there for a couple of seconds so you can check it later. And there is the bottom. I did not highlight the non-permissible values, though. Now, tomorrow, you'll be working on the lesson I'm about to teach you and writing a quiz on this stuff. Friday, you'll be finishing off everything to do with the nuts and bolts of rational expressions. Because there's no point applying rational expressions if you can't deal with rational expressions. Joseph. This D? The negative can be anywhere. There's a negative at the bottom, but it can be in the middle or at the top. Okay. All righty then. All righty then. Please turn to page. Pollen. Okay. Adding and subtracting rational expressions. You are intelligent young people. Multiplying and dividing rational expressions is exactly the same as fractions, yes? So, what will adding and subtracting be? Exactly the same as fractions, although, unlike elementary school, when you were first shown fractions and you started with adding and subtracting, I started with multiplying and dividing because that's the easier one. You're still scared of adding fractions. If I asked you to add 2/5 and 1/7, a great many of you could not have that done in your head by the time I finish this sentence, even though I'm going to continue this sentence along with lots of commas and punctuation marks until I run out of breath. And I will keep trying to keep that sentence going as I do, so you can continue to try and add 2/5 and 1/7. It's very difficult to continue this sentence, though. Do some of you have an answer? Excellent. He's tapping on his calculator. I hope that he actually did it. Oh, all right. Okay. So, add and subtract rational expressions in the same way as we add and subtract fractions. Now, let's start once again with a very easy one. Let's go with 2/5 plus 4/9. What would you do to deal with that? He waited patiently. Preston. Find the lowest common denominator. Right. Now, what is the easiest way to find a common denominator that will work? Henry. The easiest way to do it is to multiply them together, yes? That's the easiest way. Now, sometimes that'll bite you in the butt, right? For example, if you were doing 1/3 plus 1/4 plus 1/2, some of you would say, 3 times 4 times 2, I'm going to use 24. Will that work? Of course it will, but is it the lowest? No, what should you use? 12, great, okay. So in this case, 9 and 5, they are going to work together, and your common denominator is going to be what? 45, agreed? All right, so the way you would have done this in grade 5, whenever you learned it, would have been you would have written 45, and your thinking process, and I'll do a little thought bubble, was 5 times 9, yes? Right? Now, what did you have to do to that to get it to 45? You had to multiply it by 9. So what do you have to do to his numerator? 9, which gets you 18 plus, had to multiply that by 5, so got to multiply that by 5 to get 20. Agreed? And then you would have had to simplify. Now, technically what you have here is 18 45ths plus 20 45ths, right? And if you simplify both of those, you get 2 fifths plus 4 ninths. Damn it, that's exactly what we were asking, right? So what we actually have to do is add them up, 68 45ths, and, 38 45ths, idiot, 38 45ths, and then you would try to simplify your answer, yes? Does that answer simplify? No. Everybody cool? Easy peasy, no problem, right? Right? Okay. What's different in rational expressions? There can be polynomials and stuff in the bottom. Or the top, for that matter. Right? So, all we got to do is apply all of this knowledge, but instead of having a single number there, we've got a polynomial. So, we still find an LCD. Now, again, does it have to necessarily be the lowest common denominator? Or can we get it done with any common denominator? We can get it done with any common denominator, yes? Now, what is the easiest way, and I'm going to highlight the CD part of it. What is the easiest way to find a common denominator? Multiply them together. What if you had 3 denominators? Multiply them together. What if you had 4 denominators? Multiply them together. What if you had 17 denominators? Multiply them all together. It will work, won't it? Okay. So the easiest way to do this is to multiply them together. Now, stop for a moment. I said multiply them together. Did I say expand them? No. Because when we expand, when we have to simplify, what do we have to do? Factor. If we're just multiplying them together, aren't they already in factored form? So when we have to simplify later, they're already broken down for us. Everybody with me? So, I would like to remind you, I would like to suggest multiplying them together. Don't expand. That sounded loud. What would be the second thing you would do once you have decided on your LCD? Or your CD, for lack of a better word. Pardon me? Right. We would adjust our numerators accordingly. Now, what does that mean? What did we do to our numerators here? Right. We multiply by the same factor. And what do you think our third step is? Just like it was here. Simplify. Everybody cool? When you see it in action, you'll be like, oh yeah, it makes perfect sense. Is the first one difficult? Why not? It's already got a common denominator, right? So do I have to make any changes? No. So, it's over B, and it's 2A, minus a minus 1, right? Right? Now you bring all your math knowledge to the party. Is there something you can do there? What? Manru. Ashneet. 2a minus a plus 1 over b. Then what? A plus 1 over b. Am I done? Not quite. B can't equal what? 0. Now I'm done. Everybody cool? All right. Let's look at this one. Is there a common denominator? Yes. So I go over x plus 4, right? Did this denominator change? Did the numerator need to change then? No. 2x. Plus, did this denominator change? So does the numerator change? Nope. 8. What can I do there? Now what can I do? There. Factor out a 2. Now what? Cancel it out. Answers 2. What's my NPV? -4. Everybody see? All right, let's look at the third one. Already got a common denominator, yeah? So none of the top needs to change. Can you see anything to do there? Of course you do. It's x plus 5 and x minus 2 over x minus 2. Now what? Cancel, cancel. And our final answer, x plus 5. Any problem when they are not, or when they have a common denominator? No, nothing new. If you can do some math, you do it, right? Okay. What? Oh yeah, sorry, forgot the NPVs. X can't equal 2. All right, what makes 4 different? It does not have a common denominator, right? What's the denominator under 3? 1. Okay, so, damn, it doesn't have a common denominator. What's the easiest way to get a common denominator? Multiply it together. X squared, xy. Agreed? Agreed? Okay. We don't want to expand, and you'll see why in a minute. What part of the denominator is missing from that term? X squared. So what does this need to multiply by to get this? X squared. So what does this need to multiply by? X squared. What's 2x times x squared? 2x cubed. Plus, what does this term need to get this? xy. So what does this guy need? xy. So it's going to be 4xy, right? What does this guy need? Everything. So x squared xy. That, up here, we're going to expand it. X cubed y, right? So minus 3x cubed y. Agreed? Any problems there? Stop me now if there is. Because that's about as easy as it gets. And if you can't follow me right there, I got to slow it down. Is everybody good? Okay. My numerator is now 2x cubed plus 4xy minus 3x cubed y over x squared xy. Yes? What should I do now? I finished the adding, just like if it was a fraction. What's your last step in Mrs. Bag Crumble's class? Simplify if you can. Well, these are polynomials. What simplifies a polynomial? Starts with an F. Factor it. What can come out of the numerator? How many x's? 1 x, leaving me with 2x squared plus 4y minus 3x squared y. Right? Over. What can come out of the denominator? X. X. Leaving me with x squared y. Because when I take an x out of there, I've still got, if I take that x out, then I've still got an x squared, yeah? Everybody cool? Now, what do you see? You see a common factor in the numerator and the denominator. What is it? So what do we get to do? Cancel it out. What's left? And there's my final answer. What can x and y not be? X can't be 0. Y can't be 0. Ease bees lemon squeezy, right? Turn the page over. What do you see? You see yucky denominators, yes? What should you do every time in math you look at something and go, ugh? Why, what is the word you all use for math that starts with a D and ends with a T? Difficult. What is the opposite? If something has been made difficult, what should you try to do to it? Make it, choose a different word, make it simple. What's the verb for making something simple? So what should I do every chance I get in my math class? Simplify. Do you see anything there that simplifies? Where? No. Anything else? Preston. This is what they teach you at teacher school. I'm supposed to sit here until you come up with an answer. But of course, at teacher school, they think that kids... It's not a wild guess. It's not a wild guess. It is absolutely what you know how to do every time you see it without even thinking about it. Yes, y squared minus 4 is the difference of squares, so you simplify it. Now, what would you say is your common denominator? Y plus 2 and y minus 2, because you needed them both here, right? So if you multiplied this by y minus 2, don't you have a common denominator? Everyone agrees? So there's my common denominator, yes? Does this term have that common denominator? Yes or no? Okay. So if that term's denominator didn't change, did its numerator need to change? No. So I have y squared minus 20. Plus, did this term's denominator change? Yes, it did. What did the denominator multiply by? Y minus 2. So what must the numerator multiply by? Y minus 2. So what am I writing here? Okay, you could write y minus 2 squared. That would work. What's another way you could write it? y squared minus 4y plus 4. Right? Now think back to the 9th grade. What do you want to do with that? It's a 3-word phrase that you've been hearing. It's almost like I taught you before. What is y squared plus y squared? 2y squared. Plus negative 4y, negative 4y. What's negative 20 plus 4? Over y plus 2, y minus 2. Now, without giving anything away, what should I do now? He looked pointedly at the numerator. You want to factor it. What should he do now? He said, again, looking pointedly at the numerator. Factor. What should he do now? Looking pointedly at the 5 factors which he has found. Cancel. Which ones? And what would your final answer be? Is it possible some clown would expect you to write 2y minus 8 over y minus 2? Yes. Let's look at number 6. Okay, stop your knees from shaking, stop your teeth from chattering, calm your bladders down. You needn't lose bladder control, because all you're going to do is apply everything you've been doing since the 6th grade. Manru? What value? Forget about it. Okay? You guys always get hung up on the wrong thing. Don't worry about it. What should I do? I should simplify first, yes? Okay. I'm going to change color completely. What's that? What's that? Yes? Okay. What is my LCD now? X plus 3 needs to be there. X minus 2 needs to be there. And X plus 1 needs to be there. Right? What does this guy need? X plus 1. What does this guy need? X minus 2. What is that multiplication? X squared minus 1. Minus. What is that multiplication? Yeah? What should I do there? What is x squared minus x squared? Gone. What's negative 4x? Positive 4x. What's negative 1 minus 4? And, of course, x cannot equal -3 to -1. Okay? All right? Now, look at number 7 and really get control of your bladders. Because number 7 is very frightening. Until you think about it. What frightens you here? It's a fraction on a fraction. What does that line mean? Divide. So isn't this just 1 plus 1 over x divided by x minus 1 over x? Okay. So if I gave you this, 3 plus x divided by x minus 7, what would you do? Oops, sorry. What would you do? You can't do anything right now, can you? Unless you know what x is, right? But if you know what x is, you're good to go, yeah? Okay. So what if I gave you 3 bracket x minus 7 divided by 4 bracket 9 minus x? What would you do? What would you do with this? I'm not asking for any kind of answer because you can't give me one. I'm asking you what you would do with that expression. What would you do, Harsh? That's the first thing that would hop into your head? You would expand it, wouldn't you? Because you would try to deal with the yuckiness here, yes? So again, if you have an idea of what to do when it's easy, why wouldn't you try that when it's difficult? So what do you think you should do here? Simplify it. Okay, well, what is this guy's denominator? 1 over 1 plus 1 over x. What's this side's common denominator? X, because 1x is just x. What is this side missing? So what's 1 times x? X. What's this side missing? 1, but it's got 1. It's 1 times x. Is it missing anything? So does the numerator change? No. Divided by. What's this side? X. What's x's denominator? 1 minus 1 over x. What's its common denominator? X. What's this guy need? So, x squared. What's this guy need? Nothing. Now, doesn't this look exactly like what you've just spent the last 3 days doing? So this, scary. Applying some pretty basic math, not scary. What do you do to the green stuff now? Reciprocate it. Why? Because I'm dividing by a fraction. X plus 1 over x times x over x squared minus 1. Now what? You could cancel your x's. Boom, boom. What would you be left with? X plus 1 over x plus 1, x minus 1. Now what would you cancel? Gone, gone. What's the answer? 1 over x minus 1. Now, are there shortcuts? Yeah. Will I show them to you? Absolutely not. Because that is what is wrong with you people. You've been taught all your 9 times 7 shortcut garbage, and now none of you can do any frickin' math. So if you want to find a shortcut, find it. Quiz tomorrow on multiplying and dividing. Then we will do work on this stuff.